In programming, subroutines are an essential tool used to structure code and improve its efficiency and readability. A subroutine is a self-contained block of code that performs a specific task and can be called upon as needed throughout a program. By using subroutines, developers can avoid repeating the same code multiple times, making their programs more concise and easier to maintain. Instead of rewriting the same sequence of instructions in different parts of the program, a subroutine allows the developer to write the instructions once and call the subroutine wherever required. This not only saves time, but also reduces the likelihood of errors, as changes to the logic only need to be made in one place. Subroutines are designed to carry out a set of instructions that accomplish a particular task. For example, in a game, a subroutine might handle the logic for moving a player character, such as updating position coordinates, checking for collisions, and rendering the new position on the screen. In a financial application, a subroutine might calculate interest on a loan given certain parameters. By encapsulating these operations into a single subroutine, the code becomes modular and easier to understand. Subroutines are particularly useful for breaking a complex program into smaller, more manageable pieces. Each subroutine can be developed, tested, and debugged independently, allowing developers to focus on one task at a time. This modular approach also promotes reusability, as subroutines can often be reused in other parts of the program or even in entirely different programs. Functions are a specialized type of subroutine that always return a value to the part of the program that called them. This makes functions particularly useful when a computation or operation needs to produce a result that the program can use elsewhere. For instance, a function might take two numbers as inputs, add them together, and return their sum. The returned value can then be assigned to a variable, used in another calculation, or displayed to the user. Functions are often employed in mathematical and data processing tasks, such as finding the maximum value in a list, converting temperatures between Celsius and Fahrenheit, or calculating the area of a shape based on its dimensions. By returning values, functions enable programs to perform dynamic and flexible operations. When working with subroutines and functions, it is important to understand the distinction between local and global variables. A local variable is declared within a subroutine and can only be accessed or modified within that subroutine. Once the subroutine finishes executing, the local variable is destroyed and its value is no longer available. This isolation helps prevent unintended interference between different parts of the program and ensures that the subroutine operates independently of the rest of the code. For example, a local variable used to count iterations within a loop in a subroutine will not conflict with a similarly named variable in another part of the program. In contrast, a global variable is declared outside of all subroutines and can be accessed and modified by any part of the program, including all subroutines. While global variables provide a convenient way to share data between different parts of a program, their widespread accessibility can lead to unintended side effects if multiple subroutines modify the same variable in conflicting ways. For instance, if two subroutines both update a global counter, the program's logic may become difficult to follow, and debugging errors may become more challenging. As a best practice, global variables should be used sparingly and only when it is necessary to share information widely across a program. By combining the power of subroutines, functions, and variable scope, developers can create organized, efficient, and scalable programs. Subroutines reduce redundancy and improve modularity. Functions enable computations that return values, and the careful management of local and global variables ensures clarity and reliability in how data is handled. Together, these concepts form the foundation of effective programming practices, allowing developers to build robust and maintainable software.